Hello everybody, this is Kurre. Please subscribe my channel if you like this video and share. Please put your comment. Today I would like to explain how to calculate quantum numbers such as principal, azimuthal and magnetic by using Schrodinger wave function. Here the Schrodinger wave function can be expressed as a product of two wave function. Those are one is radial function and another one is angular function. The radial function represented as a psi r and angular wave function is psi theta phi. The radial wave function, it will depends on small n and l. Small n is principal quantum number, small l is azimuthal quantum number. And angular wave function, it will depends on two quantum numbers. One is azimuthal quantum number and another one is magnetic quantum numbers. If you want to calculate the principal quantum number, we have to see the radial wave function. Means with help of radial wave function, we can calculate principal quantum number as well as azimuthal quantum number. If you want to calculate the magnetic quantum number, we need to see the angular wave function. With help of angular wave function, we can calculate the magnetic quantum number. Means here, but azimuthal quantum number we can calculate by using radial wave function and angular wave function. Why? Because so here both radial wave function and angular wave function, they are depending on azimuthal quantum number. So that's why we can calculate azimuthal quantum number by using radial wave function and angular wave function. So here one example, psi 2, 0, 0. So it is in the form of n, l, m. So here n equal to how much? 2. L equal to what? 0. Means what is the subcell? 2s. Means how they will ask the questions? By giving radial wave function, they will ask to find out how many radial nodes, how many angular nodes present in particular subcell or orbital. For example, this is the one of the radial wave function. So if you want to calculate the number of radial nodes or number of angular nodes, first we should know the quantum numbers, principal quantum number, azimuthal quantum number. Means how can we calculate principal quantum number and azimuthal quantum number? By using radial wave function. Next, and for example, by giving angular wave function, they will ask to find out magnetic quantum number or azimuthal quantum number. Means so with help of radial wave function we can calculate principal quantum number and azimuthal quantum number. With help of angular wave function we can calculate azimuthal quantum number and magnetic quantum number. Now I will give some example. These are the radial wave functions. So here with help of these radial wave function we need to calculate principal quantum number and azimuthal quantum number. So before going to calculate, we should know the small trick. It is very important. If you know this, we can calculate simply. So in that first one, in exponential form, the coefficient of a0 equal to n. Means by seeing the radial wave function, if you want to calculate the principal quantum number, in exponential form, the coefficient of a0 equal to principal quantum number. Here what is the exponential form in this radial wave function? This is the exponential form. Here what is there? a0 is there. Means a0. Before a0 what is there? Nothing is there. Nothing is there means that is what? 1. Means so what is the coefficient of a0 here? 1. Means principal quantum number equal to what? 1. Next, so here this is the second one. This is the exponential form. The exponential form of a0 equal to, this is the exponential form. The exponential form of the quotient of a0 equal to what is there? 2 is there. Means n equal to 2. Here also quotient of a0 equal to what is there? 2. Here the quotient of a0 equal to 3. Here the quotient of a0 equal to 3. Here the quotient of a0 equal to 3. Means so here this is the simple trick to identify to calculate the principal quantum number. from radial wave function. In exponential form, the coefficient of a naught equal to principal quantum number. Next, azimuthal quantum number. So here one small trick is there. In pre-exponential form, the lowest degree of r equal to azimuthal quantum number. In pre-exponential form, the lowest degree of r equal to n, azimuthal quantum number. Next, see here in this radial wave function. In this radial wave function, it is constant 2z by a naught, z by 2a naught to the power of 3 by 2. These all are constants. So means before here what we need lowest degree of r. Means here there is no r, means r power what we can write r power 0. Means these exponential form, if you multiply with r power 0, again we will get same exponential form. Means here what is the lowest degree of r? 0. Means L equal to what? 0. L equal to 1, L equal to 0 means that is what? 1 is subcell. Okay. Next, this is the exponential form. So before the exponential form, this what we have to call pre-exponential form. In this pre-exponential form, what is the lowest degree? Here constant is there. The constant we need to multiply with r power 0. Here r power 1, r power 0. R power 1 means highest degree of r is 1, lowest degree of r is 0. Means if it is there constant in the pre-exponential form, the constant we need to multiply with r power 0. Means what is the lowest degree of r? 0. Means L equal to what we can write? L equal to 0. N equal to 2, L equal to 0. So what is the subcell? 2s. Simple. Next, so here this is the exponential form, this is the pre-exponential form. In pre-exponential form, r is the z r by a naught. Means here what we can write? There is no constant. Means r power 1. Means what is the lowest degree? 1. L equal to what? 1. Means it is what? 2p. 2p subcell. Next, in this radial wave function, this is the exponential form and this is the what? Pre-exponential form. So here what is there? Constant is there and here r power 1, r power 2. R power 2 is highest degree of r and lowest degree of r is nothing but what? Here what is the what I told you, if it is there constant, the constant we need to multiply with r power 0. Means r power 0. Means L equal to what? L equal to 0. Means this is which subcell? 3. Yes. So next I would like to say 3D. After saying 3D, I will say about 3P. Now listen here. So here these I thought 3D. Let me calculate. So here n equal to what? 3. Now see here. So what is the lowest degree of r? Z r by a naught to the power of 2. Means so here what we can write? Z square r square by a naught square. Means r square means what is the lowest degree of 2? R 2. Means L equal to what we can write? 2. Means it is which subcell? 3D subcell. That is which subcell? 3D subcell. Next you can n equal to 3 is there. Now see here. So this is the pre-exponential form of radial wave function. This I am going to take out. Then here what we can write? Zr by a naught into 6 minus z a naught. So here constant is there. If you multiply with r power 0, then L equal to 0. That is wrong. So here these we need to multiply with z r by a naught. So if you multiply with z r by a naught, what we will get? 6 z r by a naught minus z r by a naught. Now sorry, z square r square a naught square. Okay, we are going to multiply with z r square by a naught. 6 z r by a naught minus z square r square by a naught square. Now so highest degree of r is 2, lowest degree of r is what? 1. Here r power 1 means here n equal to 3 is there. L equal to what? 1. Means it is which orbital? Means which subcell? 3p subcell. 3p subcell. Okay, still we have calculated principal quantum number and azimuthal quantum number by using radial wave function. Next we need to calculate magnetic quantum number and azimuthal quantum number by using angular wave function. Now see here, so here this is the one of the angular wave function. First I will say the small trick. Sin to the power of mod theta cos to the power of L minus mod theta e to the power of iota m phi. Now for example the given angular wave function, for example sin theta cos square theta e to the power of I 1 phi. So this is the angular wave function. From this how can we calculate magnetic quantum number and azimuthal quantum number? See here, what is the power of sine? Here there is no anything, means 1. Then here what is there? Sine to the power of mod. Sine to the power of mod m means here what is the power of sine? 1 means magnetic quantum number m equal to, we can write 1. M equal to, we can write 1, that is plus 1 or minus 1, afterwards we will discuss. Now what is the cos square theta? Cos square theta, here L minus mod m. So here mod m means, that is if it is there minus 1 we will write plus 1 only. So here L, here what is there? Cos square theta means L minus m equal to, we can write power of cos. L minus m equal to, we can write power of cos, means here what we can write? L minus m equal to, what is the power of cos? 2. The power of cos is 2. Then we got m. Next we can calculate L. You can substitute in this equation. Then L minus 1 equal to 2. Then L equal to, we can write 3. So here L equal to 3, m equal to 1, that is plus or minus or, plus 1 or minus 1. Here what is there? Exponential, you can see exponential. So here exponential, what is there? Positive is there. Then that is m equal to plus 1. The magnetic quantum number equal to plus 1. So in this way we need to calculate. For example, another one, in the given angular wave function there is no sin theta term. In the given angular wave function there is no sin theta term. Then m equal to, magnetic quantum number equal to 0. Next, in the given angular wave function there is no cos theta term. Then L minus m equal to 0, we have to write L minus m equal to 0. When in the given angular wave function there is no sin theta term, means m equal to, we need to write 0. In the given angular wave function there is no cos theta term, means L minus m equal to 0, we need to write. Next, so here e to the power of I m psi. So at that time the magnetic quantum number is positive. E to the power of I m psi, at that time the magnetic quantum number is what? Positive. Next, e to the power of minus I m psi, at that time the magnetic quantum number is negative. So here these are the important points we need to remember. Next, one by one we need to calculate. So in that first one, next see here, I would like to say one thing. So in the given wave function, if it is in the form of r sin theta cos phi, that is the orbital, that is px or px. Next, for example, the given angular wave function, it is in the form of r sin theta sin phi, that is what? Y, that is py. Or next, if r cos theta, the given angular wave function, it is in the form of r cos theta, means that is what? Z axis, means that is present on Z axis. Now see here, the first example, what is there? Listen clearly. So r 4 comma L 1 by 2 root pi, means in this given angular wave function there is no sin theta term. There is no sin theta term. Means there is no sin theta term means m equal to what we can write? 0. M equal to we can write 0. Next, in this angular wave function there is no cos theta term. Then what we can write? L minus m equal to 0 we can write. Now these m equal to 0 you can substitute in this equation, then we will get L equal to how much we will get? L equal to 0 equal to 0. Then L equal to what? 0. L equal to what? 0. In the here what is there? 4 is there. 4L means n equal to what? 4. L equal to we got what? 0 means n equal to 4, L equal to 0. Then that is what? 4s. That is what? 4s sub cell. That is about first one. Next, second one means here the first one is 4s. Next, second one, in second angular wave function, here also there is no sin theta term. Then m equal to what we can write? 0. And there is no cos theta term. Means what we can write? We can write L minus m equal to 0. Then m equal to how much we got? 0. L minus 0 equal to 0. Then L equal to what? 0. M equal to 0, L equal to 0. Here they have given principal quantum number 2. The principal quantum number equal to 2. Means n equal to 2, L equal to 0. That is which subcell? 2s subcell. That is what? 2s subcell. Means that is about second one. So here second one, what is the subcell? 2s. Next, third one. See here, what is the third one? Root 3 by 4 pi cos theta. Root 3 by 4 pi cos theta. First, here sin theta. There is no sin theta term. Means here m equal to what we can write? 0. Magnetic quantum number equal to 0. Next, cos theta is there. What is the power of cos theta? 1. Here there is no anything, means what is the power? 1. Means what we can write? L minus mod m equal to we can write 1. Why? Because the power of cos is 1. Here m equal to how much we got? 0. Then L minus 0 equal to what we can write? 1. Then L equal to what we can write? 1. L equal to 1. L equal to 1 means that is which subcell? P subcell. L equal to 1 means that is which subcell? P subcell. Now already I told you the given angular function, if it is in the form of r cos theta, what is the here what we have to write? Z means that is what? Pz atomic orbital. Pz atomic orbital. So here this is about third one. This is what? Pz atomic orbital. Why? Because in this given angular wave function there is no sin theta term, means m equal to 0. Here cos theta term is there. What is the power of cos? 1. Then L minus mod m equal to 1. Then m magnetic quantum number we got. What is the magnetic quantum number? 0. Then L minus 0 equal to what? 1. M equal to what? 1. So here that is which subcell? P subcell. This is the third one. Next, fourth one. What is there? Under root 3 by 4 pi sin theta sin pi. Sin theta sin pi. Now sin theta sin pi means, so here sin theta term is there. So what is the power of sin? 1. Then magnetic quantum number equal to how much? 1. Magnetic quantum number equal to 1. Here there is no cos theta term, means L minus mod m equal to what we can write? 0. So m equal to how much we got? 1. Then L minus 1 equal to 0. Then L equal to what we can write? 1. L equal to what we can write? 1. Next, it is what? Sin. It is what? Sin phi. Means it is in the form of r sin theta sin phi. Means L equal to 1 means that is which subcell? P subcell. and it is in the form of r sin theta sin phi, means it is which atomic orbital? Py atomic orbital, means here what we can, I am going to write Py atomic orbital. If it is there sin phi term, it is negative linear combination. Negative linear combination means here magnetic quantum number equal to -1. When if it is there sin phi, the sin phi it is negative linear combination, then magnetic quantum number equal to -1, means it is what? Py atomic orbital. Next last one. What is there? Under root 3/4 pi sin theta cos phi, means here sin theta term is there. What is the sin theta term? Means what is the power of sin? 1, means magnetic quantum number equal to how much? 1. And in this there is no cos theta term, then L minus mod m equal to what we can write? 0. M already we got how much? 1. L minus 1 equal to 0. Then L equal to how much? 1. Means that is what? P sub cell. P sub cell means here sin phi equal to negative linear combination and cos phi equal to positive linear combination. Positive linear combination means here m equal to how much we got? 1. That is what? Plus 1. The magnetic quantum number equal to plus 1. Next, the given angular wave function, so it is in the form of r sin theta cos phi. R sin theta cos phi means it is what? Px. It is what? Px atomic